Hi, everybody. My name's Richard Woolston. I'm the data science manager at America First Federal Credit Union. We're a larger credit union that's based out of Ogden, Utah. We are in, I like to say, we're in all of the states west of the Mississippi, except for the states that touch the Mississippi here in the US. We're about 17 billion in assets, and we have over a million members. As far as details about the data science team, I run a team of five right now, and it comprises of machine learning engineers and data scientists. So what I would like to talk today is about our feature store journey and where we started to how we got onto Hopsworks, and then where we're going now that we have Hopsworks. So the way that I like to start that journey is always talking about what I call prehistory. And a good way to set that up is kind of how the data science team is set up at America First. We operate much like a hub and spoke at America First, meaning my data developers are core competency shops. We maintain tools and practices and support a lot of embed analysts that are kind of out with the various products and things like that. We also act like internal consultants. And what that allows us to do is we don't own anything, but we kind of help. And we have this large enterprise scope. So along that path, what we've had to do is we've had to develop several products, being kind of a core competency, and we've had to deploy lots and lots of data objects. So when we first started doing this, this was about 8 years ago. A data developer would sit down, they develop some sort of code, right? Let's just say this is membership attributes. Once they got to membership attributes being in a good place, they would then email the DBA with the code. The DBA would say, hey, let's go ahead and get together in a conference room. Because at this point in time, the DBAs were the only ones allowed to make changes on the centralized enterprise RDBMS. And often it would take some time to coordinate this. And as we would do these deployments in the conference room, there would be a lot of issues with these deployments. And environments were not always in sync. So there was kind of a lot of live troubleshooting. So what this led to is often we would have to take several months to make deployments, to tune those deployments, because you never do the deployment or the product requirements right the first time. So we'd have to do several iterations of these. So it was fairly slow. Some of the other issues that we had on this was, SQL itself is a great language. What it really lacks is, I would say, ubiquitous or a mature testing tool, such as PyTest or unit test in Python. Java has similar frameworks, and I believe there are also unit testing styles in R. And because we were so focused on these low-level issues, we weren't focused on the more strategic level issues that we should have been focused on, such as the data model. So that was one of the downsides. Was we would often end up with features that were calculated in multiple places, such as length of membership, balance, and those types of things. Just because we were so focused on the lower level drudgery, there wasn't time to how do we strategically hold all these things together. So we did this for a couple years, and then we asked ourselves, there has to be a better way. And one of the ways that we first started to iterate on this was Python. So we moved into a CI/CD architecture. We onboarded the Atlassian SDLC stack, and we were really good at deploying Python code several times a day and getting it out with low change failure rates. Now, what this really put a friction point on was our database layer. Our database layer, we still had to get with the DBAs, we had to have them push through changes, and kind of all this clunky stuff that we were talking about kind of in the prehistory where we were. So we ended up looking around and saying there has to be a better way to deploy SQL code, and especially now that we have all these pipelines. So one of the tools that we found was Redgate, and Redgate is an excellent tool for migration code and other SQL needs and things like that. So we were able to plug this into the pipeline, and now developers were able to make changes, push that into the migration, and push that all the way out into production without needing the DBAs along the way. So this really helped shift a lot of this development cycle to the left. Another one of the core issues that we had to flesh out along this journey was the fact that and especially educate the organization on was the software development lifecycle is similar, but also uniquely different from the analytic development lifecycle. Early on in this journey, we were always told like, hey, you need to build your data products in test. But the problem with test is test had loads of testing with tester sim records, which are never great for building data products, because as you build the data product, it's kind of a discovery, iterate, discovery, iterate, discovery, iterate. as the data tells the story, you build the product, which then dictates how you deploy it. So as we matured this process more and more, that was another one of the big things was now we created a low latency production environment. So we went in probably the span of 2 or 3 years, we went from, emailing the code to deploying that way to not really having a good development environment to now we have a low latency production environment. We're using Redgate to go ahead and manage those deployments, get them in pipelines, get them out to the database, and shifting as much left as possible. At the same time, we added other tools such as Great Expectations into the environment, so that way we could test the data as it flowed through the system. Now, the one thing we did was we removed a lot of the developer friction, which really brought to light a lot of the runtime issues we were having. So the enterprise RDBMS being a centralized managed area was not a great place for us to need to backfill or run things quickly, just because it's really a tragedy of the commons type situation and unknown query support. So when we'd have to backfill, we'd have to time these things for the weekend. So that way we wouldn't bring down the data warehouse for other people that were using it, other OLTP or OLAP systems. So this led us to say, well, now that we've iterated from here, there has to be yet another step that's an even better way, which led us to the feature store journey. And so we started our feature store journey probably around the same time that feature store started to become in vogue, which was really convenient for us. So probably about a little over 2 years ago. And at that time, when we were looking at feature stores, there were really 3 contenders. There was Hopsworks, Tecton, and Feast. So as we looked at the 3 products, we said, well, we really want to find a partner to work with. We are open to onboarding open source projects like Feast, but this is really not a product that we want to do that right now. We have a lot of other tools, Airflow, Great Expectations, and all these things that we're maintaining ourselves. This is probably not the build it yourself essentially approach, which is Feast. And then as we look at Tecton and Hopsworks, one of the other things being a financial organization, we're a little behind on the cloud transition. So we needed to find a partner and a tool that allowed us to first deploy on-prem and then convert it to the cloud. And Hopsworks is an excellent tool for that. So that was one of the deciding factors for us choosing Hopsworks among a couple of others. So that eliminated Tecton. So we went ahead and we deployed Hopsworks. And the ROI was pretty quick. So our core focus when we deployed Hopsworks into our ecosystem was to get all of our training sets. So we had lots of effectively dimensions and facts that we had collapsed and why to get those on the Hopsworks. So underneath the hood, Hopsworks uses Spark to go ahead and execute its transformations and its movement across the data layer. So once we started implementing and learning Spark, the nice thing was we now had native test infrastructure within it. So we were able to use PyTest and unit test, and our change failure rate was way down, which meant we deployed faster, we deployed quicker. So it took us about 3 or 4 months to get a lot of our core, what we call feature groups and Hopsworks up and running and getting the data scientists onboarded. Now, as we found as we deployed into this newer architecture and moved away from SQL, not only was our code quality higher and really measurable, honestly. I think it's hard to measure the code quality of SQL, but our runtimes were faster. So as we ran jobs in Airflow that then kicked off jobs in Hopsworks, we were seeing jobs complete in 15% and even 33% of the time that they would on within the RDBMS system. So what that allowed us to do is when we looked at backfill scenarios anymore, we weren't looking at taking weeks or several days to go ahead and backfill stuff. If we had to make a change to the data, we could really backfill our entire ecosystem on some of our larger data sets in maybe a day plus, not much more than that, which is a huge game changer for the things that we need to do. And especially for keeping nice, clean, good data. And what that also allowed us to do is there were a lot of features and calculations that previously we just were not going to take on because the RDBMS system just couldn't keep up. It couldn't compute it fast enough, which is really bad when your tool is effectively dictating strategy. But now we no longer have to do that. It's no longer a can we, it's, well, let's do it. Let's get it in the backlog. Let's get that feature in and let's get it running. So So what we found too is that as we've onboarded additional data developers into this, it's much faster, right? Because now we have a testing framework. And so as they make changes, we can make much bigger changes quicker because we have all those testing frameworks that come around PySpark, such as PyTest and unit tests. Now, that's the left-hand side of the equation. And now on the right-hand side of the equation, we have the data scientists. So the data scientists are also able to onboard much faster and really effectively run their jobs much faster because Hopsworks is really focused on, a shopping cart. I shouldn't say really focused, but one of the main attributes of them is they basically have a shopping cart like experience for their features. So it's easy for data discovery. It's easy to bring things together. And once you bring things together, it's easy to export again in your Jupyter notebook and go ahead and run the models you need and then move those models on. So this also brings into one of the highlights of one of the other massive benefits of Hopsworks is Hootie underneath. So beforehand in the RDBMS, we had to create those change data capture tables. And so a lot of our source systems were type 1. They didn't have that change data capture. So as we created these legacy data structures type 7 so that we could capture things, we had to write that structure in. Now, when we connect to these source systems, we no longer have to worry about writing that stuff because underneath the hood, Hopsworks already does it. It's a flip of the switch. So we have those source ones. The data engineers are pushing it in. Now, kind of bringing that full circle back to our data scientists, as our data scientists develop models, Hopsworks underneath the hood has both that data control and that version control. So from a compliance standpoint, as we're training different models, as we're upgrading, it's always easy for us to reconstruct, hey, you built this model. Where'd you get this data? How is it calculated? And then all the way back, which is really, really nice. On top of, like I say, the shopping cart, it's enabled our data scientists to onboard much quicker. To be honest, we're probably looking at a 3 to 4 times increase in onboarding speed, which is just amazing from a productivity standpoint. So that's kind of where we are. Hopsworks has really enabled us to, I would say, get out of the drudgery of that lower level, really start to innovate on how we want to implement things and increase efficiency so that we're just not performing redundant tasks that should really be built in at this point into data pipelines. So this kind of brings me into where we're going, which is nice because now we can really focus on these next level architectures. So as I said, when we onboarded onto Hopsworks, one of the core things that we were focused on was our batch systems. So now we're working on converting our online serving, which is pretty straightforward, especially in Hopsworks, and it's very quick. So a lot of our APIs right now are reading off of the RDBMS, and as we're running tests to convert them to this online serving, we're already seeing a 3 to 4 times increase in getting the data out as far as I/O goes and to the models, which is amazing, especially when you think of large data applications, how hungry a lot of these models become. The less time you could spend on I/O and the more throughput you can get, the better. So we're working on the online serving. We're hoping to implement that here in the next couple months in all of our stuff and complete what we're calling phase 2 of our migration off of the RDBMS, which we're really excited about. The next piece, which compliance, probably not a lot of people get excited about, but anytime I can find a tool that can really automate and help with the compliance aspect is amazing. So as I talked before, as the data scientists on my team train models, so they're in Jupyter Hub, they're connected to MLflow, they're experimenting. And as they're checking in models, we're connecting that to Hopsworks training sets, which are version. And so the nice thing is when the data scientist says, hey, I iterated a bunch, I'm ready with the model, let's go ahead and deploy it. And we do the model review when they go and they push it into the registry to then be deployed. Our systems go ahead and say, great, we've got to send this out for validation. One of the joys of being in a financial driven organization, we have to have a second and third line go ahead and validate those things. So, but because we have Hopsworks and we have all these pieces interlinked, as our CI/CD goes out, it goes, hey, this model version blah was trained. Oh, you were trained off of this Hopsworks version, Hopsworks dataset. You can go out to Hopsworks, land the data. Once again, really helping with the reproducibility of things, which is nice. It took us a little bit to get there, but it's really nice because one of the things you don't want to be in a validation is, hey, are you sure this is the right data set? How did you do this? And all those things. So it's really helped us start to fine tune that, which has been amazing. One of the next things we're really focusing on, once again, because we're out of the drudgery of these lower level tasks, is lineage. Really cleaning up the lineage, which Hopsworks out of the box has really good, lineage, and now we're connecting that to the enterprise data catalog, and so that way we can get our power business users and product owners in there, really creating rich documentation and engaging in the platform, so that moving forward, it just creates a nicer, well-documented system, and not really the self-documenting dream that people are always chasing, but let's take care of this lower level stuff so that people can get in and really focus on that really nice documentation rather than connecting things. Finally, the last piece that we're really focusing on with Hopsworks is, for a while, we've been using the open source version of Label Studio, and as we test and deploy models, we commonly have our product owners and our business owners go back through, say, hey, do you like this prediction? Do you not like this prediction? Yes, no. And so right now we're going to work on connecting those two things, so that way we can say, all right, data set comes out, the subject matter expert goes ahead and does what we need. How do we then get back there to Hopsworks and basically create this really nice, rich life cycle, so that way we can get as much information back into the system to then have a positive feedback loop in the future, so we're not losing information as we go along. So that's been our journey, and it's been quite the ride. And so that kind of wraps up where we're going. There's probably a lot of things that we're going to have on the roadmap into the future. But to be honest, this conversion from really this prehistory all the way to Hopsworks feels like an amazing transformation that's really enabled us to be innovative to a point that previously we wouldn't had to have had. And there's just so much richness baked in the tool that it's allowed us to focus on these things moving forward. So that's been our journey on the Hopsworks. It's been an amazing success for us, and we look forward to working with the team into the future. Thanks everyone for taking the time to listen. If you have any questions, please reach out to the folks at Hopsworks. I'm sure that they would love to discuss in a lot more detail than we can kind of go into this presentation. But once again, thanks everyone for your time.